Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Ingo Simonis. Ingo is the Chief Innovation Officer at the OGC, OGC standing for Open Geospatial Consortium. And today on the podcast, we cover a lot of ground. So we start off talking about systems thinking, natural systems, human systems, ecological systems, the role of geospatial within these systems. Ingo even ties this into the idea of location systems. So this moves really quickly on to smart cities, digital twins, climate change, the idea of creating digital representations that model a piece of the natural or physical world. Edge computing, we talk about some of the technologies that's making this available. How technology behind virtual worlds is used to communicate complex ideas in the real world. Ingo will also share some thoughts around the tension between providers of geospatial data, geospatial products, and the consumers of it. And this conversation is going to be presented in a way like, how does this relate to big issues that we're facing, in particular climate change? It's worth mentioning at the start here that I'm producing this podcast in partnership with the OGC, and we've worked together on a few different episodes before, so I'll put links to those in the show notes of this episode. Okay, that's it from me. Let's jump into the conversation. Hi, Ingo. Welcome to the podcast. You are the Chief Technology and Innovation Officer at something called the OGC. So I've published a few podcast episodes with the OGC before, people from the OGC, I should say, and I think we'll refer back to that in the show notes so people can go check that out if they want. So we won't dive into the OGC as an organization too much in this episode, but I want to talk about some of the technology that you're developing, some of this innovation that you are the chief of. Before we do all of that great stuff, could you just introduce yourself, please? Like, who are you? How did you get involved in geospatial?
Thanks a lot, Daniel, and thanks a lot for inviting me to be here today. I'm Ingo Simonis. I'm responsible for all the research and collaborative solution development we do in OGC. I got involved as an ecologist originally, and the science behind ecology is all about the science of systems. Everything works in a system. It might be an ecosystem, it might be in any other system. It's systems that is the foundation. What I learned over the last 25 years now that I'm in this business is that geospatial and the work we do within the Open Geospatial Consortium is all about systems. On the underlying layer, it's computer systems, but what it really is, it is systems of humans that use computers. And that's how I got involved, from an ecologist to a computer scientist to a systems engineer.
So again, your title is Chief Technology and Innovation Officer. Is it hard to separate, or is it impossible to separate these technological systems, these computer systems that you're talking about before, and the human systems? How tight is that coupling, do you think?
That's a good question. The human systems or humans behave pretty much the same for the last, 50 years. That's as long as I can judge it. And computer systems evolve very rapidly. They change every couple of years. And we get new technology that is available to us, new capabilities that we can make use of. But humans do not change much. Humans behave the same way. The way humans learn hasn't changed much over the last probably thousands of years. But computer systems do. And that makes it somewhat easier because we have one stable element in there, right? And that's the human factor. So we can fully concentrate on the technology, which makes it somewhat easier for us.
I guess this system of systems gets even more complex when you think about humans using these technical systems to monitor, to observe, to model natural systems.
That's correct. I mean, we cannot model the full system. If you look at planet Earth from a space station or from Moon, you see a very complex system. And what we can do is, computers work in a discrete manner. They can only do certain things at a time. That means we can only observe certain elements within our Earth system at a time, and we can only monitor, for example, temperature at a couple of places, but not everywhere. We cannot observe all physical properties at the same time. So we need to have individual systems. But in order to get to the complete picture, to really understand how things behave, how we can influence, for example, the Earth system or any other system, we need to have a holistic view on that system. And that requires to combine those individual pieces to a bigger, larger master system.
I have a feeling that later on in this conversation, we're going to come back to this idea of systems and combining them to, to have an impact, to make things happen, to make change happen, is my guess. But right here, right now, I want to sort of bring this a little bit more down to earth. What kinds of technologies and innovations are you working on at OGC? Like, what is important to you now in the OGC, and why is it important?
Right. OGC is all about location data. And if you think about location, almost everything we do every day is somewhat linked to location. I mean, even financial data, the companies are located somewhere. Traffic data, for sure, cars are driving around, trains are on their tracks. The physical systems of the earth, like the climate, for example, everything is located somewhere. And the systems we are looking at in OGC are those location systems or those location subsystems. So we are looking at a very, very broad spectrum from climate change to smart cities to another buzzword, digital twins that we use right now for everything that we try to understand better, like a twin of the ocean or a twin of a city or even a twin of your home office. So basically, the digital representation of a piece of the natural world or the natural environment. That's what we are looking at OGC, but it's really covering an extreme broad spectrum.
So if we try and break that down a little bit further, so some of the concepts, I guess, or some of the technologies which are helping sort of drive this, making these things possible. Let's use the digital twin buzzword again, making digital models of things we care about and things we want to monitor and measure. At least in my mind, some of the things that are making these possible is the reality capture, how far we've come with that, and the technologies involved with capturing large amounts of data which accurately represent the physical world. Cloud native geospatial, so not just computing on the cloud, but also being able to distribute data via the cloud and on demand through APIs. When you think about the kinds of technologies which are driving this digital twin phenomena, what do you think about?
It's certainly a constellation of technologies. One thing that drives the digital twin is that we do have more and more computing power available, what we call at the edge, which means you can carry it with you. We have now very sophisticated cell phones and other miniature computers available so that we can do lots of processing in the environment. We do have cloud technology, you named it. So we have literally unlimited resources available to everyone. So even me as a private person, I can go to a cloud provider and request 50,000 nodes. I just need to pay for it. And that gives me lots of flexibility. And at the same time, what we see now, and I think this is one of the major shifts we are currently experiencing, is that we are making lots of advancements or enhancements in the visualization technology and in the combination of gaming and real world. So if you think about the computer games, they provide sometimes super photorealistic sceneries. You have really the impression that this looks like a video capture, even though it's fully computer generated. But it took place in a virtual world in the past. And what we see now is this shift from, or this combination of the technology behind the virtual gaming worlds and the real worlds. And that, I think, is one of the biggest advancements that we have made over the last couple of years that will really help to better communicate what's happening in our environment or within any of these systems that we would like to understand better, to explain to others, or to communicate in general.
So I want to come back to the idea of communicating what's going on, in these digital twins that in just a second. But I think this is really interesting. You're saying one of the biggest leaps forward has been in the visualization stack, I guess you could call it. And up until now, I've been thinking about digital twins as their output mostly been an answer, like a single answer, yes, no. Can I see this building from this point? Yes, no. Is this a good place to put a power line? Is this the optimal distribution of these 5G antennas, like yes, no kind of thing. Like, where should I put these things? And I've never really thought about it that what we're missing is perhaps the visualization side of things. Can I walk through this environment? And if we can capture the real world in a realistic amount of detail, we can start to simulate that. So it seems to me when I think about it like this now that we have this confluence of a couple different things here. We've got the technology stack, and we've probably also got the cultural stack. So people are used to gaming, so been playing very very realistic games, as you mentioned yourself, for quite some time now. And the combination of those two things is really interesting. So I guess my question from here is, so what does that mean when we can start to move away from creating and interacting with synthetic worlds and move into like representing the real world and interacting with the real world? What are we going to use that for?
If you look at how humans imagine the world, the mental maps we do have, or the way we dream, we see things being oriented in space and time, right? So that's a fundamental way of imagination. And now imagine you are the mayor of a larger city. You have $20 billion available to further develop your city. What do? You only have 20 billion, right? It's not that you have unlimited resources. You have quite some money, but you cannot build all the new infrastructure, better isolation for the houses, solar, everything, and so on, plus 6 new subway lines. It's not possible. You need to decide on what to do. And now imagine you have a bunch of printouts available, a bunch of tables and charts. And from this information, you need to derive your decision. You need to base your decision on this type of information. And now imagine you see your city computer generated, and you can click a couple of buttons on your keyboard and you see the different scenarios. Here you see what happens if you invest your money into new green infrastructure. Here's what's happening if you invest your money into a new subway system. Here's what happens if you invest into any other component or constellation of aspect. And the modern technology gives you the opportunity to visualize those different scenarios. And then you can even add another set of models that tell you what's happening, right? How are people behaving suddenly because they have this new subway line available? Maybe you just relocate your traffic jams from one area to another. Maybe they disappear. Very often, it is so much easier to see what's happening or to get a better understanding how things look like once you have visualized them. I mean, there's a good reason architects build the mock-ups, right? It's not that you get a sketch on a piece of paper and that's about it. No, you get a three-dimensional mock-up, and based on that mock-up, you make your decision. And now imagine you have a living mock-up, right? You can fly around it, you can dive into it, you can zoom in, you can zoom out, and you can combine it with the simulation models that simulate human behavior and the responses of the environment to your measurements. And I think that is the key point in the new technology, that you can much better understand how things would look like if you take decision A, B, or C.
Is this something that you're actively working on today?
That's one of our biggest work items. The underlying challenge is that you need to integrate lots of data sets, right? You do have all the data. I mean, if we come back to the example of our city, you have the population, you have the traffic, you have the behavior of the people throughout the day. You do have communication lines, you have the lifelines, wastewater, freshwater, energy, what's not. You have all these individual systems. And in order to get to these holistic pictures, in order to get to a realistic visualization of all these elements, you need to integrate data that has been collected over the last sometimes 100 years. And it is in all sorts of formats, in all sorts of different systems. And the integration is a big challenge. And that's what we are working on. Well, since we have started the OGC 28 years ago.
So this might be a dramatic oversimplification, but when I think about something like this, I think, okay, well, I try and split it up into two groups. So for me, you talked about we need lots of different data and we need to integrate that into these models. So maybe if we split it up into two groups, we've got providers and consumers. So people that are going to have input into the models, help create these things, these technologies, which is going to make this possible, and people that are going to consume it on the other end. I'd be curious to hear what do the providers say? Like, what's stopping them from doing something like this? What's getting in their way, or what do they want out of something like this?
The difficulties for the providers is that the consumer side is not homogeneous, right? It's not that the consumers say, this is what we want. If you are a consumer of the power grid system, for example, and you just want to use power to recharge your cell phone, then you have a complete different view on the power grid compared to another consumer who needs to maintain it. And from the provider side, right, you need to satisfy those very specific needs of a very heterogeneous set of consumers. And that's a challenge for the providers. They need to understand how to serve data to the various groups, and they need to understand how to serve it in a way that it is economically efficient, right? It's not that you can just serve everything in lots of different formats for the fun of it. I mean, all these aspects, all these initiatives costs money, and so you need to be selective. And the big challenge is to pick for the right solutions, and that's what we are working on, right? Trying to identify what to use on the provider side, and we are trying to identify how to best consume it on the consumer side.
So let's talk about the consumers for a second. What do they want? Like, or what problems are they facing? Like, how is this model, these digital twins, how is it going to help them? What do you hear people saying on the consumer side in terms of geospatial? What are their problems?
Again, very heterogeneous, right? Take, I mean, I'm living here in a small city in Germany with 11,000 inhabitants, but the city has exactly the same challenge as New York City or Copenhagen. We need to understand what climate change means for us for over the next 20, 50, or 80 years, because there are a number of fundamental decisions we need to make to face climate change. So we need to understand lots of things. Climate change means for us, well, what is first the current situation? How much precipitation do we get? What's the temperature variation throughout the year? What's the solar radiation? And so on. A couple of aspects that we need to look at. Then we need to understand how things change or might change depending on the next 20, 30 years and to a large extent human behavior. And then we need to understand how we can adapt to these changes or maybe mitigate them. So, what we actually need on the consumer side is, in this example, a very large set of different data sets. If you're just interested in optimizing your traffic system in the city, well, you need to understand almost real time traffic situations, and then you can run a couple of simulations to further optimize it, right? So, the more you approach a simpler problem or a more concrete problem that is depending on less variables, the less data you need, the easier it is to model it and the easier it is to implement it. But those fundamental changes, like climate change, for example, right, these require very large sets of data, and not large necessarily in the sense of big data. I mean, some of it certainly is, but large in the sense of lots of different data.
Are we sort of moving towards a world where it's not so much different data inputs, but it's more like different models working together? So you're talking about it's much more simpler to solve some of these problems or to come up with an answer if we're very specific about the kinds of problems we're trying to solve. Are we moving towards a world where it's not one model, not one size fits all to answer the question of climate change, but we're like multiple models working together to answer the problem? Like, what does climate change mean for the city that you live in, for example?
Yeah, I mean, there is never a single solution to a challenge you have. And there are always those underlying factors that, depending on how they influence your system and how they behave, you may need to take decision A, B, or D, right? It is the natural environment and the human-made environments. They are both very complex, and modeling them always means that you need to simplify, and it always means you need to reduce to a certain level of input variables. And that is not only to climate change and those big challenges, right? You can use a relationship with your partner. You cannot model it in all detail, right? You need to observe a couple of physical properties, and then you can probably generate a couple of models what reaction you can expect depending on your next step or your behavior. But it's always simplification. And the challenge is, to pick the right variables and to interpret them in the right way. But given that there is not a perfect answer and there's not a single solution, you always have those different models that, depending on the input you give them and the parameterization and the way you tweak them, give you different results.
When we think about like visualizing the potential outcomes of climate, if we go back to climate change, maybe we should pick an example like flooding, for example. The increased risk of flooding because of this overarching topic of climate change. Do you think about like visualizing these kinds of things for the decision makers, or do you think about visualizing them for the masses, for people like you and me, which aren't in a position to make decisions about which way we should go, which technology we should invest in?
Well, often you and me, we are decision makers, right? We see this nice lake and there is some space you can buy to build your house on, and you go to the lake, you imagine how nice of a view you would have from your living room, and you buy the space. And I mean, look at all the rivers in the country, right? How many have houses built left and right to it? And how often did the now owners of that space run a simulation and figured out what's the risk of flooding for their direct environment or for their property, right? Probably very rarely. So I think visualization techniques certainly need to talk to the people, and visualization techniques, I can imagine, make the difference because there are flooding maps for all rivers available, for at least for the major rivers, and probably in most parts of the world, but nobody looks at them. Right? It's a painted map, it's a printed map, and there's some blue shaded areas, and you think, okay, well, how do I interpret that? Does it really affect me? And in most cases, you don't even look at them. But imagine you see a visualization where you can zoom into your future property and you think, okay, this is where I would like to build my house. And then the simulation says, okay, you can now choose from 3 climate scenarios, 1, 2, and 3. And then you click the first one and you see that there's a major precipitation event and your house is flooded. And you think, that's bad. You click number 2 and your house is flooded again. You click number 3 and your house is flooded again. And then you're out of options. And you think, wow, if that are the 3 most likely scenarios for the next 30 years, and in each one of them I see my house being flooded, you have a complete different perception of that, right? It's not that we want to create anxiety. Oh my God, I'm certainly confronted with flooding, but we want to create this awareness, and we want to allow people to experience what the situation is for their direct environment and not for something abstract that is printed on a map.
Do you see an environment like that, a visualization like that, as being a modeling tool, the kind of tool you go in and make calculations? And obviously, it's a simulation tool, but where people measure things. Well, how high was the water? How compared to my house? That kind of thing. Or do you see it as as perhaps a marketing tool?
It's certainly both, but climate change is marketing, right? I mean, the fact that we have a human induced global warming is not new. And how many people have built or solar panels on their roofs, or how many people have reduced the number of air miles they take? Or, I mean, how much behavior has changed over the last 30 years since we have climate change in the media every second day? That's very little. So, on the one side, it needs to be a marketing instrument to market we need to do something. And on the other side, it is an information instrument that helps you to better understand your environment. But we always see that, oh my God, there is this thing called climate change. We need to do something against it. Well, you need to market it in 2 directions, right? On the one side, you need to further communicate it, to really communicate the consequences and the possible adaptation strategies. And on the other side, I mean, it's a big market as well, right? Someone needs to explain all those cities, counties, countries, what the situation will be. Someone needs to implement mitigation measurements. Someone needs to create mechanisms for carbon sinks and so on. So on the one side, yes, it is a big challenge for all of us. On the other side, it is a big business as well.
So oftentimes when people in our industry and in the geospatial industry, when they're building things, that they might say things like, people don't want data, they want answers. And I can see that for the decision maker side of things. Do you think that holds true when we think about marketing to consumers, to again, to people like us, non-decision makers, people that aren't in the local governments, people that don't have the mandate to decide which mitigation strategy we should be using? Do you think that idea of people don't want data, they want answers still holds true?
Well, first of all, behind every answer, there's a long tail of science that probably was performed against the data. And then at the very long workflow of raw data to analysis ready data to decision ready data to the final decision, right? There was lots of science and processing was already done. But do people want simple answers? That really goes into the psychology of decision making. Often people do want to select from simple answers. It's not that they want to have the single answer, right? Do this. But it is often so difficult to take a decision because you only have a very limited set of information available. Take, for example, if we stick with climate change, right? You need to decide to burn coal or to burn natural gas for heating and for power production. Well, theoretically, gas is probably more eco-friendly than the coal. On the other side, if you take all the methane and all the other gases we release in the atmosphere during fracking, during the exploration of the gas from the underground storages, the picture suddenly has a complete different message to it. And it is so difficult to understand all these aspects. And we cannot dive into everything every time, right? To which extent can you do an echo analysis of the next car you do? It's impossible, or it would take for ages, and you don't want to invest so much energy. So on the one side, we need to reduce the decision space to a number of options. And on the other side, we need to reduce the information space because you cannot absorb all this information and integrate this into your decision process.
It's funny. I was talking with someone about LiDAR data quite a while ago, and one of the things that stuck out to me was them saying like 98% of working with LiDAR data is filtering the LiDAR data. Finding out like what is meaningful in this massive amount of data, filtering it down, making it easier to understand. And I guess that's what I'm hearing from you now. That the biggest job here is filtering out, reducing. I think you call it the decision space. And I thought that was brilliant. This idea that people don't necessarily want one answer, they want to choose from a bunch of simple answers or simple decisions. That makes perfect sense to me. Like, so when I think about this, so I think about we've got this technology which is enabling the kinds of visualizations that we're talking about, which is again going to democratize access to this stuff. Democratize being the latest buzzword, but it's going to make it easier for people to see, like, how will this affect me here now? Because we can model their real world environment, we can make it personal, and we can model how the environment might change over time. We can make it, and it's for them. It's not somebody on the other side of the world. This is going to happen to them. These are potential realities for them living in this space. But I guess we just need to agree on what those potential realities are. Do you think if we had that, if there was some, maybe on a country level, maybe on a regional level, perhaps on a go level, we could all agree that these are the potentials, like these are the potential realities for people living here at this scale? Do you think that would make it easier, or do you think that's a blocker for implementing the kinds of things that we're talking about now?
Well, that's a tough question. We do have some agreement in some areas. If we take climate change again, we have the IPCC, the International Panel on Climate Change, and they have created a number of possible scenarios, right? The scenario we continue behaving like we did the last 30 years, up to the we all become super eco-friendly scenario. And certainly the extremes might be a bit less relevant, and the reality or the truth might be somewhere more towards the middle. Well, at least that's what most expect. Then we do have let's say, a selection of possible realities that we can choose from, or at least a selection of possible predictions that we can select from. Can we agree on a reality? The answer is certainly no. There are always people who enjoy the way things are, and there are always people looking at the same situation and think that this needs to be changed. And there's a complete different perception behind it. And it might be the result of a different contextualization, might be the result of a different experience made in the past. It might be the result of living now versus I have children and I want to make sure that their grandchildren have a fantastic planet to live on as well. So can all of these people agree on a single reality and a single interpretation of a reality? Certainly not. But can we create a subset of most likely realities for the upcoming future? I think so. At least we can and we need to create these things because we are now building the digital twins, which means we are now building the mechanism that can allow me to understand what's the current situation of this environment. And this might be a lake, a river, or a city. So we are getting there. We are integrating more and more data. We will never integrate everything. That's certainly not realistic, but we are integrating more and more data. So we better understand our lake, for example, or our system. So once we have this understanding, we can now run the simulations to predict the future. And here, for sure, we can say, well, one is more likely than the other. But agreeing on a single one, that will certainly not work.
So, we talked about some of the technologies involved in building these environments before, and we've come a long way, and it's incredible the kinds of solutions we're seeing to these very, very like deeply technical problems. It totally blows me away what we can do today, and I think when I look at the trend line where we're going in the future, it's almost hard to comprehend. But there's another side of this equation. We've talked about this as well. So that's one side is the technical challenges, which are massive. But I think we've got a huge cultural challenge as well. And you touched on a little bit there before, like getting people to accept these are the estimates. Can we agree on that? Because if we can't agree on the outcomes of these models, then what's the point of the model? Because if it's easy for you to say, or if everyone says, well, we don't like the model, we'd like a new model. I mean, what's the point of the model? It seems to me this is a yin and a yang thing. These things need to go together. From where you're sitting, and you sit in a rather unique position. You see both sides. You see the technical challenges and you also see the cultural challenges around this. If I could wave my magic wand today and solve one of those challenges, all of the tech challenges or all of the cultural challenges, which one would you pick? Which one would you want me to solve for you?
Uh, wow, that's a tough question as well. Because do I want to address the cultural variety we have? Well, certainly not, right? So it is like the decision if you prefer a democracy or a dictatorship approach. I mean, for sure, it is easier to take a decision in a dictatorship approach. But do you want that, right? And that's the same challenge we are confronted with here. I think what we would benefit tremendously from would be if people are more agreeing into providing data and providing processing capacities to the greater good. So more open data, more data that is accessible, more data. Well, first of all, you can discover it, right? That's the first point. Then you can access it, and then you can use it within your applications that then generate new knowledge about our environment. So the more we can bring together, the better we can take the decisions. We will always be confronted with those decision spaces, right? Where we need to select from the options we have, and we can only choose a couple of the options we have. But I think this is the great thing about our society is that we can come together and we can in a consensus process decide, okay, we use these elements out of the decision space and not all the others. That's certainly not something I would like you to address with your magic wand because I'm not quite sure how this would develop. But the magic wand is certainly a very good option on the technology side. And even here, right? People have different concepts. So your concept of a tree is different from my concept of a tree. You may think of a green structure that produces oxygen, and I think of a more yellow to red structure because we are in the autumn here in Europe, and it's just a beautiful thing that makes me smile. Right? It's two different concepts we have, and we as humans, we understand that we are talking about different things, and we can adapt to each other's concept very quickly, and then we can continue our conversation. That is super hard for machines, right? Machines do not necessarily understand that they are talking about different things. And if you could use your magic wand in a way that we would uplift our current systems to systems that better understand what the other machine is talking about, that would be fantastic.
I'll get to work on that.
That's good.
I think perhaps this is the first time where I've really thought about the importance of data diversity in terms of inputs for these models. Like obviously, well, not even obviously, like when you say more data, I think that's one thing you were saying. I think one of the things that would really sort of push us forward was open data, more easier access, like just diversity of data, more of it, please. You know, from different sources representing different things in different ways, perhaps. Like I understand that the cultural problems around not existing on a map and not existing in some of these labeling data sets that we see, not existing as not being represented in the labels that are going into creating these models. But this is kind of the first time I've thought about this way more generally. More data. If everything was open, if everything was freely available, this is obviously like a dream world that I'm living in. But that idea, if we could get more diversity in general in our data and the way we access it, we could open up things dramatically. I think that was a really good point you made there.
And that's an experience you always make when you address a specific challenge, right? You have a new hobby, for example. First, you let's say you want to go into cycling. First, you just buy a bike and you go off and take a ride, and you enjoy it. But then you enjoy it so much that you want to understand how you can train more efficiently because you want to cycle faster, and then you get into the elements of aerodynamics and of how to train most efficiently and intervals and what's not, right? So you always start with a very high level view on a certain topic, and then you dive more deeply into it. And exactly the same thing we have with the data spaces. So you look at the Earth system from the ISS, for example, from our space station, and you understand parts of it, right? And then you dive deeper and you want to understand more, and you want to understand what the reaction of the system to your stimulus. So you take some actions. How is the system behaving? And you want to understand this at all those different levels, because you can influence every system at different levels or different scales. And the more you work with these systems, the more you want to understand the reaction to your actions. And that requires more and more data, right? Whenever we fire up a new satellite into space and we get finer resolution, maybe one pixel was 50 by 50 meters, and the next generation gives you 20 by 20 meters, and then you have 10 by 10 meters. Once you have 10 by 10 meters, you want 2 by 2. Once you have 2 by 2, you want 1 by 1, right? It's always the same thing. You want to understand everything down to the, well, I mean, we are working on the subatomic level, right? That's not necessary to address all those grand challenges we have, but you want to have a very fine-grained data at very high temporal resolution. Once you have a satellite that overpasses your area of interest once a day, you would appreciate if it would do that once an hour, because there are certain processes you can only understand at that temporal frequency. And yeah, that always leads to the next generation of data, and always leads to the desire to have finer granules or more resolution for the data that you're working with.
I can definitely see that, you know, how that works. So I have a system, I see how it's working at this one resolution, temporal, spatial resolution that I have, and I understand it leads to more questions which can perhaps only be answered by a finer resolution, a finer temporal or spatial resolution. Do you see the business models moving fast enough to sort of support these efforts?
In many situations, the business model is still, I observe something, generate a product out of my observations and maybe a bit of processing and sell this. So the very reduced observe, process, sell path is often the favorite business model because A, it's easier to understand. B, it provides you a much easier return of investment because you know how much you need to invest and you're not dependent on others and so on. So that is still the favorite business model. What we often want is generation of knowledge. And generation of knowledge doesn't transfer easily into an return of investment. If you understand how your river system will behave let's say in a heavy rain event, that has the potential to save you billions of euros because you may you can influence the river system and maybe you can prevent the next big flood. But it hasn't happened yet, right? So do you implement this system that may costs quite a lot of money just for the case that something might happen? You have the knowledge engineering that you need to do before you can even implement the system because you want to know what can you do, right? How can you influence your river system so that it will not respond with a major flood if there's a major rain event? So first you need to do the knowledge engineering, but that requires already lots of data products to be used. And then you are not even there. Then you have the knowledge what you would need to do. And then the next step would be to implement that knowledge and influence the physical system. But even then, you don't have any return of investment yet because this big rain event hasn't happened. And then you need this next step for the big rain event to happen in order to get some return of investment. And I mean, that's hard for private industry, right? To implement all these steps just for a possible scenario. And that's why we often see that much more reduced processes are still in favor. And from a single company's point of view, I mean, if you can provide a full environment with hardware, with sensors, and then some computers that collect the sensor information, do some processing, and then you can sell data on top of it, and everything works within your own environment. You have your own data formats, you have your super secret transfer protocols, and so on. It's all within your environment. So you lock in your customers, right? Once they are buying into your system, you have no problems with competitors anymore because they don't know how your system works internally and how it behaves and then what data structures you use and so on. Well, that's from an economic perspective of that single company, that might be an interesting approach. From the perspective of trying to understand how things behave on a more, let's say, holistic level, it's a nightmare because you want to integrate as much as possible and you need to integrate, as we have seen before, so many things, right? So there is a huge discrepancy between what some industry players, not all, some industry players try and what others need. It's often different with smaller companies. Smaller companies often see their niche in exactly this open space. But we see large cloud providers now selling hardware, right? And we see large hardware providers now selling software services. The big ones try to lock you into their ecosystem. The smaller ones often try to be successful with the more open systems.
This is sort of going back in the conversation a little bit, and I apologize for this, but I'd like to ask you anyway. Up until now, we've been talking about the advantages of doing this kind of stuff, the advantages of leveraging the technology that we have today, the advantages of making it available to people through these visualizations that we talked about, of modeling what the environment might look like, these sort of possible realities that we talked about, what we can do with that. We've been talking about it, at least in my mind, from the perspective of this is a good thing. Like this will help you make better decisions. This will save you money. This will reduce the risk. But when I think about the private sector, there's oftentimes you're motivated by the short term, the here and the now. And my guess is that a lot of people, if they knowing all this means that they could be at fault. Oh, you knew that, but you did it anyway. There could well be an incentive to not know, to not invest in any of this and continue the business as usual model. How do you see this changing over time? Like, do you think? I imagine, for example, like people are going to require this kind of due diligence more and more, like, and be thinking longer term. But it seems to me anyway, we still think very much in the short term, and we're incentivized to do that.
It's certainly very often that we think in the short term and the direct return of investment. That's true. But even if you think in the short term, if you need to look for your fiber cables underground and the first time you start digging for your cables, you hit 5 other cables and create bigger outages, and you're responsible for it, and you may need to pay compensation, then you are even in this very short, narrow time span you're looking at, you are interested in these additional data sets, in this more holistic understanding of the local situation. And if it's only a small hole you dig into the ground to get to your single cable.
So I feel like we've come full circle. We're back to this idea of integrating data, of making it available so we can make better models, better predictions, and then we can show these to the world. It's here that this is what it might look like and help get people invested in these possible outcomes. What can we do right here, right now? Like what is missing in all of this? Like what is, can any of us listening to this podcast do something that would help speed up this process?
What we can do, certainly in the space of the data provisioning side or the consumer side, and that I think is affecting most of us, is two things. First, we can agree on standardized formats and interfaces so that we can discover and use the data. That is one thing. And the more standardized this process is, the easier it is to integrate new data into your application and into your system. And the second aspect is we need to allow variety at the same time. And how does it work? Well, you need to define in a very unique way how you have done certain things. You need to define what your concept of, for example, a tree, a road, a house was, how you sampled the data, right? You need, because everyone does things differently, we need to have mechanisms in place that allow the variety. Okay, you use your model of a tree, I use my model of a tree. But because we have identified the way we see our world and we make the view on the world available to the others, even machines can understand that they are talking about the same or not the same thing. And that helps then to integrate even a large variety of data set that were sampled using different protocols, different mechanisms, different purposes in mind for the data to be used, and we can still use that data. And yeah, if we can work towards these two aspects, the standardized models and interfaces, and on the other side, the shared conceptualizations, then I think we have made a huge step forward that would help us better understanding our environment and taking better decisions in general.
I just want to touch on one point here, just to make sure that I'm on the same, that I've understood this correctly. When you're talking about these shared concepts, it sounds to me like you're talking about metadata, like descriptions of what this thing is. What is your tree? When you say tree, what do you mean? Is that correct?
That is correct, but we need to see that metadata for one person is the data for the other, right? So sometimes it is just metadata. You need to decide or to describe your view on the world. And on the other side, this data might be what others are looking for, right? And in this case, for them, it becomes their data.
Hey, thank you very much, Ingo. This has been an incredibly enlightening conversation. I really appreciate your time. But before I let you go, I want to ask, do you have any great examples where people can go and perhaps look at some of the work that you're doing at the OGC, or try out some of these environments that we've been talking about, these visualization environments, anything that would perhaps sort of inspire people to get involved, or to help them understand that what the future might look like? Is there anywhere where we can point people towards where they can see these things in action?
If you run a search query for scientific visualization, you certainly find lots of good examples. At OGC, we are currently working on a what we call a persistent demonstrator, a demonstration that is always available 24/7. You can play around with it. This is currently in the setup phase, so this will be available later next year. But there are already very good examples available. We need to find more examples for this integrated 3D space. We need to combine it more with those mechanisms that sell to other generations, right? It's not that we can sell scientific visualization to the younger generations, but if we go through the metaverse or other mechanisms, we might be much more successful, not producing things on a big screen, but somewhat on a cell phone screen, or even augmented realities or fully virtual realities. There are lots of things we need to produce, and these things will become available over the next 1 to 3 years. And I think they will give us a huge push forward towards a better understanding what's necessary, what's possible, and what we can do with it.
Interesting. I look forward to this future. Thanks again for your time. I really enjoyed talking with you.
I thank you very much, Daniel. Thank you.
I really hope you enjoyed that episode with Ingo Simonis, Chief Innovation Officer at the Open Geospatial Consortium. Once again, I have produced a couple of episodes now with the OGC, and there will be links to those episodes in the show notes. That's it for this week's episode of the Mapscaping Podcast. I'll be back again soon. I hope that you'll take the time to join me then.